Hello everyone, myself Mr. F.R. Syed. I work as an assistant professor in the Department of Computer Science and Engineering at Walchand Institute of Technology, Solapu. The topic for my today's lecture is deleting a node from the end of a singly linked list, that is from the tail end. Now the learning outcome. Now at the end of the session, the students will be able to write a C program for deleting a node from the end of a singly linked list. Now let us first see what is a linked list. A linked list is actually a collection of nodes. Now let us see what are the fields that are there in a node. A node actually has two types of fields. One field is a data field that actually consists of the data to be stored, and the second field is a pointer to the next node in the linked list. Now actually we have two different types of pointers in a linked list. That is, the pointer to the first node in the linked list is actually called as the start, and the pointer to the last node in the linked list is called as the tail. Now this tail pointer is optional, but we need to compulsorily have the start pointer so that with the help of the start pointer the other nodes of the linked list can be reached. Now when the list is initially empty, we can say that the start pointer will point to null, indicating that there are no nodes present in the linked list. Now there are four types of linked list. The first one is the singly linked list that we are going to see in this lecture. The second one is the doubly linked list, where we will be having actually two pointers, that is one pointer to the next node of the linked list and one pointer to the previous node of the linked list. Similarly, we have another type of linked list, that is the circular linked list, where we can say the next pointer of the last node will be pointing to the first node of the linked list. So therefore the named as circular linked list. And in that circular linked list we have two different categories, that is singly circular linked list and the doubly circular linked list. The singly circular linked list is actually a singly linked list where the next pointer of the last node will point to the first node, and the doubly circular linked list is a doubly linked list where the next pointer of the last node will be pointing to the first node and the previous pointer of the first node will be pointing to the last node of the linked list. Let us see exactly what are the different fields of the singly linked list. As we know that there is a data field and the pointer to the next node. So in a singly linked list there will be only one pointer that will point to the next node, whereas we know in a doubly linked list there will be two pointers, one pointing to the next node and one pointing to the previous node. Now this is true for all the nodes of the linked list. So here we have a diagram that indicates a singly linked list, and you can see the first node has the data 5, then the next node has data 10, 20, 1 and so on. Now every node has a next pointer that points to the next node of the linked list, and the next pointer of the last node actually points to null. So it indicates that here it ends the linked list. So if we are going to implement this with a programming, we are going to make use of struct node, where we are going to have two fields, that is one is data field of the data type integer and the second one will be struct node star next, that is a pointer that will point to the next node of the linked list. Now today we are going to see, out of the multiple operations that we have on the singly linked list, the operation of deleting from the end. Let us first see this algorithm. We are going to first of all start our algorithm by checking whether the start pointer is pointing to null. If it is so, then we are going to just display a line that the linked list is empty. Otherwise, we will conclude that there are at least one node in the linked list. So in that case, we are going to traverse and reach the last node of the linked list and then make the temp pointer, temp is actually a temporary pointer, to point to this last node so that this node can be deleted. So after temp has reached the last node, so in that case free this memory that is pointed to by the temp pointer, and then the task is over. Now we have a question for the students. Now the students are expected to think and write the answer to the following question. Now the sequence of operations is, first of all 80 is inserted at the end of the linked list, then 10 is added at the end, then 100 is added at the beginning of the linked list, and then finally 60 is added from the beginning. So in that case, what will be the elements in the linked list if the node is deleted from the end? So now pause the video and write your answer. So we'll see now how are the elements added. First of all, 80 is added in the linked list from the end. Now since the linked list was empty initially, 80 will be the first node in the linked list. Then 10 is added at the end, means 10 comes after 80. Then 100, if it is added at the beginning, it comes before 80. And finally when 60 is added at the beginning, 60 comes before 100. So now our aim is to delete a node from the end. So in that case, we can assume that this node 10 will be deleted. So therefore, this is the status of the elements in the linked list. So now we are going to see the program for this. So in this program also, since we need to delete element from the end, we need to have the code for insert from beginning and insert from end of the linked list. So we have already having that in this program. So we have declared header files, we have declared the definition for node, that is structure node, then the prototype declaration for insert from the beginning and insert from the end functions, and I'll add the prototype for one more function, that is struct node star of delete from beginning, struct node star. And of course we have the prototype declaration for display function. Then in the main function we have declared a pointer as start that will be pointing to the first node in the linked list. Start is initialized to null. Then we have a while loop in which we have a menu driven program where we have first of all displayed the options available, insert from the beginning, insert from the end, and then I give the third option for delete from end, and then option number 4 for display and option number 5 for exit, and then I ask the user for his choice. I read it in variable ch, and then switch case block will be there for accordingly handling the operations. So case 1 for insert from beginning, case 2 for insert from the end, and then I add one more case, that is case 3 for delete from beginning, delete from end, which will take the parameter of start pointer, and then I break. Of course I have option number 4 for display, option number 5 for exit, and default we have the wrong choice option. Then the code for insert from the beginning function, insert from the end function. So now our aim is to write code for delete from the end function. So I write down that function, struct node star delete from end, and then a parameter struct node star s, which will be taking the value of start pointer. Then I declare a temp pointer in this case. Along with that, I also need to have a ptemp pointer. Then I check if start is equal to null. In that case, I display that the list is empty, and I return the value of s, which has not been updated. Otherwise, I'll have to check whether there is only one node available in the linked list. So that I'll do with the help of this statement, if s arrow next is equal to null, meaning this node that we are going to delete is the only node in the linked list. In that case, what are we going to do is we are going to just delete this node, that is first of all temp equal to s, and then we are going to print this line, that is %d deleted, and %d will be replaced by temp arrow data. Then s will be equal to s arrow next, that means s will now point to the next node which in this case is null, and after that I'll free this temp pointer and return the updated value of s. So this block was for the scenario when we have only one node in the linked list, which after deleting this node we have the linked list as becoming empty. So after that we have to handle the situation where we have 2 or more nodes in the linked list. So for that case we are going to write down the code now. We are going to first initialize temp equal to s, and while temp arrow next while temp arrow next is not equal to null. So in this case now I'll be taking another pointer named as ptemp, so which will point to the current temp, and then I'll be moving the temp pointer ahead, that is temp equal to temp arrow next. Now this ptemp pointer has been taken so that when we are going to delete the last node from the linked list to which temp will be pointing, ptemp will be pointing to the previous node of this temp pointer. So why? Because the ptemp arrow next should be made equal to null after deleting the last node. So when we come out of this block, we have reached the last node to which temp is pointing, and ptemp is pointing to the previous node. So in that case what we'll do is ptemp arrow next will be made equal to null, and then we are going to print the line of the element being deleted, that is %d deleted. So %d will be replaced with temp arrow data, and then we are going to free the temp pointer, and ultimately we are going to return the updated value of s to the main function from where this function was called. So now we are going to run this code. We'll first select the C language as the language for this program. Okay, so here by mistake I have written delete from beginning, it should be delete from end. So first of all I insert an element at the beginning as 20, then I insert an element at the end as 40. I just see whether the elements have been inserted properly, 20 and 40, yes. Another element if I want to add at the beginning, let us suppose I add element as 30. So then I display the elements 30, 20 and 40, and if now I want to delete an element from the end, in that case 40 should be deleted. So let me check whether 40 is deleted. Yes, it says 40 is deleted, and after I display the elements it shows that 40 is no more there in the list. Another element if I want to delete from the end, 20 should be deleted in this case. So when I display the elements, it shows only 30 is present in the linked list. So that is how you write a program for deleting a node from the end of the linked list. Now this is the reference used for the video lecture. Thank you.